rates of change. Rates of change in section 2.1. So this is part 2. So when we look at rates of change, we have like average rate of change. And so that's having two y values and subtracting those two y values divided by subtracting their x's, right? So that's average rate of change. Or we could put it in this form, their change in y over the change in x. So maybe see that in physics or something. And then we have our instantaneous rate of change. So instantaneous rate of change is where we're taking the limit as our change in x goes to 0, right? So as this difference between this difference gets closer and closer to 0, right? So that's instantaneous rate of change. Yes, rate of change. What's it changing right now at that instant? And the change in x and the change in y, those are called increments. So here we look at the derivatives, or the instantaneous rate of change. So the derivative that's our instantaneous rate of change, so f prime of a. That means we're looking at the rate of change at a certain point a. And so we see like this one's pretty small. So this is a small change, where this one right here, that one's a large change. So here my slope, or my derivative, my rate of change, all those are interchangeable words, is close to 0, right? Because 0 would be flat across here, where this one is more almost, it's not almost vertical, but it's getting closer and closer to vertical, so it's getting larger and larger to a bigger and bigger slope. So then we'll look at some types of derivatives. So we talked about average rate of change, and then that's kind of like secant. And then our tangent is instantaneous velocity. So our derivative f prime of a is just like the velocity. So this s stands for the position function. So f of t means at what position, given a certain time, is our like some type of maybe molecule or something, where its position is. And then so the derivative of that would be its velocity. So we have its velocity, and then the speed of it is just looking at the absolute value of that. So the absolute value of the velocity. So because it's not a molecule, a particle traveling, so this is its position function, and it could go, if it's going this way, then it's just a positive, and if it's negative, then it's traveling back this way. And so it's just, this position function just tells you where it's at, the particle's at, and so when you take the derivative, that tells you the velocity, and the absolute value of that is its speed. So the particle might travel this way, and then it turns around, goes back this way, and then goes back this way. So that's kind of one example of types of derivatives is velocity, and that uses the position function and taking the derivative of that to find out the velocity or the speed. Here are some other examples. So when we look at the cost of something, so the cost of producing X yards of fabric, so we have a cost function. So that's our cost function. And then we can go ahead and calculate its derivative. And remember, when we calculate the derivative, what that means is that we're finding the instantaneous rate of change at that specific time. So when we calculate this derivative, we're looking at what the units would be. So when I find the average here, the instantaneous average rate of change, it's looking at how much dollars are changing per yards that I'm producing. So it's the dollar change over yards changing. So those are my units. How much it's changing, the cost is changing over how many yards I'm producing. So how much is that next yard going to cost? All right, so I might start at 30 yards, and then how much is it going to cost for the 32nd yard, right? So this is a certain price. Say this is $200, right? And then for 32 items, it's going to cost $225. So when I find the instantaneous rate of change here, and I'm looking for that rate of change, it's the change in dollars amount over the change in yards. So how much is it going to cost to produce 2 more yards of fabric? And then what does it mean? What does it mean to f prime of 1,000 equals 9? So what that's saying is just that when I produce that 1,000th yard, it's going to cost $9 per yard. Or for that, not a total of $1,000 does it cost, or 1,000 yards does it cost $9, but going from 999 to that 1,000 yard will cost $9. So that one extra yard is going to cost us $9. That's what f prime of 1,000 equals 9 means. It's making that 1,000th yard, it's going to cost us $9. So which one do you think is greater, f prime of 50 or f prime of 500? Meaning, is it going to cost more to produce that 50th yard, or is it going to cost more to produce that 500th yard? And what about the 5,000th yard? Which one of those is going to be bigger? So if you think about it a little bit, so if you're making, it's going to cost us initially to start up, it's going to cost us more money to run fewer yards, right? So it's going to cost us more than, because by the time we have 500, right, things are moving smoothly, and then so it's going to cost us more to make fewer than is 500. So it's going to cost more to run that 50th yard versus running that 500th yard. Okay, but there comes to a point where things start to cost a lot more, right? Yeah, if you're producing more and more and more and more, you might have to hire more laborers to work. Maybe you have to keep the factory going a little bit longer. Maybe you're running more shifts than just one. So that 1,000 yard or that 5,000 one is actually going to cost you more to make that one, because maybe you have to hire more people, keep the lights on longer. So this could be the right spot. This is what you want to produce in order to make the most amount of money. Because if you make too few, then your expenses outweigh how much you're making. And if you're producing too much, then your expenses outweigh what you're producing, right? So there's some kind of marginal line here, which we call the cost, or marginal cost. We want this marginal cost, which is the derivative of the cost function. So the cost function is how much it costs to produce items, right? Where the derivative, the marginal cost, is how much it costs to produce the next item, right? So f of 500, which is the same as, say, c of 500. C is the cost function. That's how much it costs to produce a total of 500 items, where c prime of 500, meaning the derivative or the marginal cost, that is saying how much it costs to make that 500th yard, or whatever our scenario is. So that's another thing, marginal cost. That's also the derivative. That's a type of derivative. All right, so that's it for this one, under 10 minutes.